Also have my ruler one. Okay. I cannot record my ruler. I cannot show that I have my ruler here. So I also place my ruler and then I also adjust until I can only see 1 point, and every time I move towards one direction, it will try to make it touch exactly 1 point, and then after that, it's very difficult. Yeah, the thing keep wanting to move. Okay, then after I adjust my ruler until it is roughly 1 point already. Never come out. Okay, so I will move my ruler, and then I move until I only touch 1 point. I don't think mine is very nice because this ruler with the iPad difficult. I move a bit, the iPad also move. Then after I have this line, when I want to find the gradient at this point, this line, if I zoom in indefinitely, this point will become a straight line. So this straight line is to simulate here being a straight line. Then if I want to find the gradient of the curve at that point, I find the gradient of this straight line. Then if I want to find the gradient of this straight line, I need two coordinates. So I go to this straight line, I look where I can find nicer points. Nicer points means it just nice at the intersection. Then it will be easier to read. So for example, this one, it cut here, it cut here. It will be easier to read my x and my y. Okay, so I will choose this as one of my points. Then when I read the x and the y, the x is easy, -4. The y is 3.246, 3.6. I have a point already. Then I need another point. So when I see, okay, this one, also at the intersection, easy to read. Then I have 0.4. If I read here, it's 0.4. If I read here, it is 2. So I have two coordinates. Using these two coordinates, I can find the gradient of this straight line. Okay? So what they want me to fill in here, at B, using the coordinates, for mine will be -4, 3.6 and 0.42. But for your graph, it's different. Because you draw a different line, your 2 points will be different. So you go and find the 2 points on your graph. Then you have these 2 points already. Then you go and find the gradient. So they help you. The gradient equation is here. Change in y divided by change in x. Help me pee a bit. Okay. So after you have these two coordinates, again yours will be different from mine. Take the y minus this y, that will give you the difference in y. If I take this y first, I must take this x first. So I will take my -4 and minus 0.4. Okay? You can key the whole thing inside the calculator, or for me, I have this one. Hey, your own coordinate will be different from mine. You don't just copy my coordinate. Your graph will be different from my graph. Because your line is different from my line already. Okay? So the answer I have is, mine is negative 4/11. Using my points. Using my points, this red line has a gradient of negative 4/11. Okay? Meaning, the gradient of this curve at point B is negative 4/11. Okay? At C, the tangent is a horizontal line. Meaning, I zoom in. This point here, the best fit of a tangent is horizontal. Can you see? The gradient keep changing. Then at this turning point, it is horizontal. Then after that, before it becomes positive. So at this point, the tangent is a horizontal line. Reha, you still talking? Okay. Then the horizontal line has a gradient of 0. Why 0? Because gradient is a measurement of how steep a slope is. Okay? Gradient is a measurement of how steep a slope is. If my slope like that is gradient 1. My y goes up by 1 when my x move by 1 also. My gradient is 1. Then if I have a less steep slope, then in 1x, it only go up by 0.5. It is less steep because every one step I only go up half already. If I have an even less steep one, every one step I only go up by 0.25. Then it will be even less steep. Until finally, I move one step, but my y never go up at all. Then it will become a horizontal line. My change in y is always 0. No matter I go how far, I still don't go up at all. Okay? Then my change in y, change in x. My change in y is always 0 because I don't move up at all. So it becomes a horizontal line. So a horizontal line gradient is 0 because no matter how far I move, I never go up at all. So my change in y never change ma. So it is always 0. 0 divided by how far I go, it is still 0. So horizontal line has a gradient of 0. Remember your y equals to mx plus c. You can have a horizontal line where the gradient is 0. Then it becomes y equals to a number. So black. At first this is the line. Then it becomes less slope, less steep, less steep. That's why I keep drawing. Then until it is totally no slope at all. When no slope at all, we are measuring the slope. No slope at all means it is 0 lor. You nothing to measure. That's why in your workbook they also never ask you to measure. They straight away tell you it's a horizontal line, so the gradient is 0. Go. Wow. You one day go so many times toilet. Toilet so fun. No. Okay. Then let us look at question 1. What gradient is vertical line? This one actually we also touched before. Like that. She go to third language lesson. Is it third language, right? Or second language? I can't remember. She has to go another school to take the lesson. Okay. You learning French, ah? Is it in your timetable one? Okay. Hey, you were asking vertical line, what is the gradient? So same, just now if 1, I go up by 1. If I become steeper, then become 1, I go up by maybe 2. Then if I become steeper, 1, maybe I go up by a lot already. So when it finally become vertical, here, my change in x, there is still 1. But then when I measure, I cannot even reach already because it goes so high. So one way we say of the vertical line, the gradient is undefined. Too high already, too big already. So we say undefined. Okay? Or you can say it goes to infinity, cannot reach. Okay? Infinitely big.
You draw my mind, waste my paper.
Okay.
I'm going.
Hello, hello.
I'm gonna unscrew every screw in your house.
What?
You go take my book and waste my paper. Walao.
Okay. For question 1.
I'm gonna tattoo this on your head.
It's all looks so like.
You are such a good actor that it doesn't even look like acting. Okay.
It's not acting.
They want you to go to the curve at this point and identify is the gradient positive, negative, or 0. So if I go to 0.16, on the curve, where is 16? 16 is 16, here. Okay. So can you tell whether the gradient will be positive or negative? There is 16, right? So is the gradient. How will the gradient look like at this point? How is the curve sloping? Okay? So if we look, at first it is sloping like that. Then it slow down a bit until here. But it is still in this direction. Okay? If I go and place my ruler properly, it will be around like that one. Okay? So if you recall, your y equals to mx plus c, all the slope that is like that one, my x higher, y also higher one, all these have a positive gradient. Sloping upwards towards the right. Sloping upwards towards the right means positive gradient. Okay? So here is positive gradient. When x equals to 4, here, I go to my curve. It is horizontal. Horizontal means it is 0. Horizontal, 0. Sloping downwards, then negative. So 11, 2. 11, 2 is here.
What?
So this part, my curve is like that. My gradient is like that. So my gradient at this point is sloping downwards towards the right. So it is negative. Sloping downwards is negative gradient. Sloping upward is positive gradient. Horizontal is 0 gradient. X equals to 13. Ah, yes, this one 0, correct already. 15 2 here. Yes, positive. Between 5 and 13. So they want between here all the way until here. Negative. It keeps changing. So it from like that, change to like that, change to like that, change to like that, change to like that. But it is always negative. It is always sloping downwards. Okay? Okay, one more. X equals to 14 and x equals to 15. Okay, x equals to 14 and x equals to 15. X equals to 14, it is like that. X equals to 15, it is like that. So although both are, hello, maybe have to chase Gabriel back to go and sit with Anson. Yeah, you see? Everyone agree. Okay, although both are sloping upwards, both are positive. Can you tell which one has a higher gradient? Which one has a higher gradient? 14 or 15? Yes, 15 got a higher gradient. Because 15 slopes up steeper. Okay? So that is what they want you all to know in this question. Okay? Gradient at x equals to 15 is larger, bigger, goes up faster. Okay, by drawing a tangent, estimate the gradient of the curve. So, this curve, the gradient keep changing one. By now you should know already. So, if you want the gradient at this point, you go to this point first. -5, -7. Okay, so you go to that point, you mark it out. After you mark it out, you go and place your ruler. Hey, your turn to do work, eh? You do already. The rest. Place your ruler and then adjust your ruler. Bring it closer to me. Adjust your ruler until only one point touch. Then you draw one line. You can draw longer, never mind one. Longer the better. Don't believe you ask Gabriel. Now his ruler short already. So longer one better. Draw a longer line. Then out of the longer line, you choose 2 points that just nice at the intersection. Then you will be able to find the gradient. Okay? Okay, I think... Okay, but I need to tell you all these do as homework. Can? Page 60. You should be able to do already. Can? Then page 62 also can do already.
No more 6, 7.
Why? Why you all laugh at my pronunciation? You all bullying me. Yeah. Now all the young people very easy. They say they feel hurt one.
Young people.
You all are the young people lah. You all. Okay. Okay. Then I will put also a form on the Google Classroom. I will need all of you to go and key in your calculator model. Okay. The school want to help you all check your calculator is approved during your N-level. So I will put up a Google form. Everyone need to go in and fill in. Okay, Reagan, Eunice, everyone need to go in to fill in your calculator model. I will put the form on Google Classroom. Okay? Can? Then this one do as homework. Then page 62 do as homework. Tomorrow, when is the next time I see you? Tomorrow, yay. I so happy to be able to see y'all, right? Okay, then we can go on to the next chapter. Very simple one. If you can plot graph, you can do this chapter already. Okay?